And yeah, we are looking for people to join for this competition as well. So that's CCDC. It happens every February, the first or second week of February. So what happens is it's a competition throughout US, but the first round is Southeast. So it's us, Georgia, and I think, let's see. And FIT is the one who is responsible for making it happen.
Did you go somewhere for this, or was this remote?
This one was remote. The only thing was you have to be in a particular place and join a Zoom with them. So it's a cyber defense competition. So you are defending an enterprise system, and mostly it's networking. That you don't even need to use like a CM at all. It's mostly just networking, trying to open and close ports in a server, trying to change passwords for the available users, set password policies. Mostly that. So let me know if you want to participate. It's next February. The early you start practicing, the better. Also, if you participate, you get a invitation to career fair, and one of the company that comes is Raytheon, and it's an aerospace and defense company with money. So, yeah.
How would you like practice and prepare for that?
So practice, we are setting up the lab right now. It said that it should be done by the end of the semester. But to learn, first thing you want to learn is become a system admin for Windows and Linux. So at least you can do a bunch of stuff. And then try to see how somebody could attack those systems and try to harden it. So nothing else, just hardening the system. That's all the competition is about in the first round. And the second round is always different. So we don't know what they will give us at all. So yeah. So if you read this, it will tell you a brief description as well. Sure, they do give us resources, but I don't know how we could have used it. No clue. They give like Palo Alto's the next gen firewall. But what do we use it if we are just excited to? Oh, yeah, not sure about that. Hey, how do you like it? It's fine. Yeah. Battery life's a little subpar. But as long as I'm here now, then the class doesn't matter.
I almost bought that one.
That does what I need to do.
Which one?
A15.
I
I think so. Yeah, like $730.
Really?
Yeah, brand new, 1 day shipping. That's why I bought it. I needed something fast.
Cool.
How's everybody doing?
Good, how are you?
So, well, did you get through any of the club announcements ready yet? Tournament, all the things going on?
Yeah, I haven't started yet, just like briefly. I just shared the link for the Zoom and Discord.
So who's on Zoom? We got a tenant?
Let's see. We have like two distance learning students that can't come, so
Okay.
hopefully they show up.
Right, find the building okay?
Yep.
So this is where the main data center is for FAU. It's not on this side, but on past the glass doors over there, that side. Is where all the main servers are, the firewall and whatnot. So we're kind of split between building we're in last time, we keep half of our stuff there. We keep the other half here. It's all running like a cluster format where it's hot. My office is in here, in the back corner. He knows where I'm at, but you have to get through those double doors. There's a phone there, and there's a directory on the wall. If you guys ever need to get a hold of me, you can go to that phone and dial my desk number. Someone will answer for you. Who's in the competition next Wednesday? 2, 3, anybody else?
3 more people have to show up.
Yeah, so we're gonna run that out of here, right?
Yep.
So we have another conference room on the other side, on the secure side, where we'll set you guys up. And I have an outside internet, Starlink, an SSID and a PSK that I can put you guys on, as well as you can run from the inside, but that's more unfettered, unfiltered internet. So you're not gonna be running behind the firewall, which could introduce like situational issues when you're trying to do stuff. Even through your outbound VPN might not work well through that. You tried it, right? Okay, so that's one option. I'll pipe a switch in there with Comcast. So we have Comcast modem type internet. You plug in, you'll get DHCP and we'd be on the outside for the tournament for that.
Start then. All right, hi, welcome again, welcome to our second meeting. So today's agenda, as I shared in Discord, is going to be terminal, SSH, Telnet, some Linux basics and some cool things. And Mike is gonna show everything and he's gonna go over everything. But before we start, there's a few things I wanna share. Some resources. So worldwide technology. So it's a great platform. So it's that right there. It's wwt.com. So once you create an account, you can go to the menu and two most important places is cyber range and labs and learning. So this cyber range over here is kind of a hackathon scenario. So like there's like a bunch of CTFs coming, capture the flag events. So just like Hack the Box or Try Hack Me, this is another one that you can do and you can participate as a team, alone, and you can practice. And there's a bunch of learning paths that you can use as well. Like to learn red tools, to learn blue team tools. So if you go to the learning series, it's gonna give you like a whole course that's five hours long, 4 hour long, right? If I go back, as you can see, I'm also learning core routing fundamentals over there, so it's a good resources. The second one is Professor Messer. So anyone who is studying Security Plus, Network Plus, or any kind of certification, you might want to look at his YouTube channel. So that's him right there. I'm gonna share everything on Discord again under resources, but that's a whole playlist to learn Network Plus. That's a whole playlist to learn Security Plus, and it's really good. So if you skim through all the videos and then make notes and then skim again, that's the best thing I realized for myself. Another one is Jeremy's IT Lab on YT on YouTube. So the one I'm using for him is the CCNA complete course. A good thing about this is he not just teaches but has created flashcards that you can practice. So you can download the flashcards under every video's description and learn. And the third person on YouTube is Elad, the computer guy. I might have shared one of his videos about TCP/IP for programmers. So this is kind of a supplemental channel. So this guy goes over a bunch of things that's required for programmers or any kind of heck professional that they must know in this time of the world. So I'm gonna share all of this on the resources, but just to start this meeting with, and share the resources with you.
Okay, what I would do is, first of all, WWT is actually a vendor. So WWT sells stuff. We're a customer at the University of WWT, and all the Dell computers that are in the labs and servers in the data room, they'll come from WWT. They're a worldwide reseller. You go back to their site, you might be able to see like where it says partners. See, those are all the reselling channels that they sell through. And we typically buy our Dell stuff from them. We buy Cisco and NetApp from another company called Presidio, which is very similar. Both are good companies, big conglomerate type companies, you know, nationwide, you know, a couple thousand employees. They have typically, if you work for one of these places, you're either, there's like three types of roles that you would have. One would be like an account manager, where you're like the sales guy, right? Another one is the sales engineer. That's the one who sells the products to the customer. And then there's actual like implementation engineers. So typically when people buy something, they'll have an implementation engineer put on with the purchase so they can assist them in installing it. So they maintain a stable of high technical people to do a lot of work. And we use both WWT and Presidio for professional services when needed. And it allows us to like ramp up and ramp down and do, let's say you have a really big project you got to do. You don't want to hire 50 people that you're not going to have next year after the project's over. So you augment with professional services to get the project off the ground, and they hand over a turnkey solution sometimes at the end. WWT is, not only is it a good platform for this learning channel that they've developed, but it's actually a good company to work for outside of here after you graduate.
Yeah.
I'm sure they track your progress in there when you go to apply for them.
Yeah.
Yeah, go look at careers. Curious, maybe I can get a new job. Yeah, so TSA, Technical Solutions Architect, that's like your pre-sales guys. Consulting system engineer, pre-sales.
Yeah, and you need a pretty high amount of experience.
Well,
And I think in all of them, I skimmed through all of their jobs.
some of them, I think there is some entry level, but what does it say for just systems engineer?
5 years.
Clearance.
Oh, and did clearance, okay.
Well, right now, the market is kind of like oversaturated with people that have experience to some extent. There you go, engineer desktop support. That's a starting role.
Yeah, oh, no.
I don't know about that.
I mean, at this point, just apply and see if it
Yeah.
works or not. Doesn't hurt.
So Client manager, you see where it says SLED accounts? SLED is what we're in the state, local, law enforcement, education, and something else. So basically, like, the SLED division sells to major institutions. It's a good division to be in if you're a sales guy because, you know, the university is a state school. The state of Florida is part of the United States. The United States has a big printing press in the back room they print all the money out in. So our budgets are quite big and it's easy to sell us stuff. You know, as opposed to like corporate businesses, they don't have that. They have to make a profit. So they run much tighter than the government does. You guys have all heard of government based. There's an intern. You got to start somewhere.
Yeah.
Those are probably paid internships, I would imagine.
Right.
But that gets you in the door and then you move from there. OIT here is always looking for people. And this will get you that 1 to 3 years experience working in this building. That'll allow you to then go take an enterprise job. And guys like that will take you in because you came from a SLED environment where you were the customer. The way they look at it is like, you already know a lot of people, you could go back in and sell to them. So they'll hire you to turn around and sell back to them. Anyway, you want me to do my thing? I'm gonna hook up my laptop. So I don't know if you'll be able to record this, but you guys can take notes. Or anybody on the remote? One person. Wonder if you share the room view. Anyway, we'll get through. They can listen. Yeah. But most of the rooms here are set up the same. I don't know if you guys have been in some of these study rooms where you have this type of setup. There's usually a restaurant control panel, your room PC, and then there's this little hookup station where you can hook your stuff up. All right. So the first thing I want to talk about is terminal emulation. Who knows what terminal emulation is? So terminal emulation, when you connect up to a device, you can console into it. Who knows what console is? Okay, use a console connection that's typically like a serial-based connection. And we're going back in history here to like the early days of computing. But terminaling was done when you were working on stuff like a mainframe. And I guess, you know what? I'll go back to the PC. So I'm just going to remote another machine in the other room. This is a lab subnet here. So you're not allowed to do certain things here. That's why I want to be laptop. To get to the secure side of things, I got to open up the VPN. Now I'm RDPing from Windows to another Windows box. This is a desktop in the other room. I just need my phone. Got one down there. How many people get Duo? You guys work with Duo? So Duo is getting renewed, so we're going to keep that for a little bit longer. Everything we do in the world has to get a do. All right. See, I got the same logo as you guys, because I made that logo. We're not really using it, but you know, I'm just a PC we put on there. So terminaling. So what I have up here is a program called Secure CRT. Has anybody heard of that program before? Okay. So Secure CRT is a terminal emulation program that allows you to establish sessions from your computer to another computer over multiple different channels. An example of a remote session would be Telnet, SSH, local shell, RDP, serial, etc. Each one has its own port numbers. So if you're doing SSH2 or SSH1, and then you would put a host number in there of what you want to check out. The host name could be an IP or a host name out on the internet. And depending on what it is, you'll get prompted with keys. SSH is a secure version of the remote. Telnet is a non-secure, okay? You can establish a terminal session over other ports other than the one specified here. So terminal sessions could go over port 22, they can go over port 23, they go over port 135, they can go over port whatever number you have set up. As long as the other incoming system is allowing to receive an open connection on that port number. What are we talking about with port numbers? So after the IP address of a remote system or the host name, there's a port number. That's a dynamic TCP IP. The TCP part of it or the UDP part of it has a well-known port number list. So if you were to look at a document, let's say we pull up Google and we were to just Google TCP well-known ports. Okay, here's a quick list of well-known port numbers that you would find out there. Okay, so port 22 is for SSH, port 23 is for Telnet, port 25 is for email. Okay, port you keep going up the list here of these well-known ones. Port 53 is for DNS. That's a very popular port because DNS is what puts our names to IPs so we can get resolution. So all of these numbers, if a system is set up to accept a port on that port number, it will open up. Now, how do you know what port numbers you have open? Well, on Windows, if you guys are following along on Windows, you can just simply bring up the command prompt, right? And the command netstat, okay, will show you what active and established ports you have open. And you can see the IP address there, and then the number of the port numbers in the list here. All these after the colon, that's the port numbers. So from this is the host, this is the remote. So this is the local, this is the foreign. Okay. SSH on 212, HTTPS on port on this address. So that's like a web page that's open. This is the SSH to CSC. You know what CSC is? csc.fau.edu is your guys' web page for the club. So I have a terminal probably in my terminal here that's open with that. And then there's some connections here to Miami and other standard connections. Now, if you wanted to know more, and these are I'm just going to run through a couple basic Windows ones before I switch over to Linux, because Windows is kind of based on Linux to some extent. And let's call it a copied port with a proprietary code set. So netstat has flags. So think if I type in question mark, there you go. So these are what we call flags. What a flag is a command that you would put in after netstat. Okay. So after you issue the command, I hit a question mark there. That question mark is like a help. It's like saying, what can I do with this command? Then you have -A, -B. So -A displays all connections and listening ports. Dash B displays all the executables involved in creating each port, each connection. Why this is important is if I go netstat dash B, okay, so you have to run that as admin. So I'm going to redo this by opening command prompt again. And then right click on this, run as administrator. That's going to give me a little bit different of a prompt, but netstat dash B. And now you can see the actual executable program that is running the connection. So this is a good way to like self-audit your system for, let's say, malware. If you don't know the executable that's running there, then it shouldn't be running. It should only be running things that you're aware of. So we have Outlook, we have Chrome. The one that gets everybody all wrapped up is this service host. But if you Google servicehost.exe, it's going to say, oh, this is an internal Windows process. It's kind of like a dummy that most places, anybody who's like a decent hacker would use that as their cover because it like passes through on systems. Now you can take a deeper look at that and say, well, what is this doing and what's it connecting to so that I understand what service host is trying to do. Windows does a lot of, I'll call it unnecessary call home features, where it's constantly trying to like reach out and get to back to Microsoft to check things, run security updates, run Windows updates to see just what you're doing. Consider it like they're spying. Okay. Now the only addresses that aren't relevant here is you see this 127.0.0.1. Does anybody know what that is? No? Okay, so eventually we'll get into the IP ranges, but 127.0.0.1 stands for the local loopback. So that's the local system. If on your computers right now, you ping 127.0.0.1, it'll ping out every time. You can turn off the internet, disconnect from Wi-Fi, and still ping 127.0.0.1 because that is inside your computer. It's not like an address that like you assign to yourself, it's automatically call home, right? So I want to show you some similarity for this to the terminal when we jump in. So in here, if I wanted to know what my IP address is, I would go IP config. There's my IP address. And I have, on this system, I have two network cards. I have one network card on one subnet, and that's actually the VPN. And then I have another network card on that subnet there. So, basically, default switch. This is a VMware that I'm running. And then this adapter is not configured, so I'm not plugged in. But this is just the desktop that I'm running. The name of the desktop you can see is Commodore 64, which is like a throwback name. I give my computers like unique localized names other than the because when we're testing out there, it's easier for me to spot that in the log than something that says like, you know, FAU System 01, whatever, that blends in with like 9 million other different things at FAU. So we give ourselves some unique names that mean something to ourselves. And then if I'm doing testing and I want to search for myself, I can find my computer. Everybody's computer has a name here. I don't know how many of you guys named your computer or not, but that's the system name. And that'll get overdubbed in DNS into your system. All right, so we've gone through some basic Windows stuff. We looked at what ports are. We looked at netstat, which is a good command to get used to on Windows. And pretty much, I wouldn't say everything I'm about to show you in the Linux side is doable, but for the most part, you can do a variant of whatever I'm going to show you here on Windows in some form or fashion. I recommend doing it on Linux. It's much more powerful, as I explained in the last meeting that we were at together, where you're in charge here. You let Windows be in charge. Windows in charge. You let Apple be in charge. You got no control at all. You can kind of do some of this stuff on there, but it's really not fully there. So what we have here is two systems. I have a bunch of different connections, but we have two systems set up. This one here is a Raspberry Pi that's running Raspberry Pi OS. It's a Debian Linux. And this one's Kali. Anybody heard of Kali before? Kali is your standard Swiss Army for doing security, auditing, penetration testing, all the good stuff. You could do black hat stuff, white hat stuff. It's basically like a prepackaged Linux system with a lot of tools in it. So I'm going to run some commands and show you some different things on each one. I have a list of them, and I can post this list of commands here for you guys. The first one's a basic one. So in Windows, if I right click here on the start bar, right click here, I can pull up the task manager. And everybody's seen this before, their task manager, they've killed the process that's loaded them up. I've also have, under the task manager, you have a couple different things that you can look at with memory and you look at apps, you can look at, what you have in processes and users, and then your services, etc. Well, the same thing is doable in Linux terminal, and we have a couple different variants of that. So the first one I would look at, and this is a standard one that's built in, is called HTOP. And I'll make this full screen. So this is a way of looking at a Linux system, just like you look at your task manager. Here we can see that we have 4 processors, we have 8 gigs of memory, we have a 200 meg swap file, we got some uptime, we got processes running, there's not much running on here, where the processes are. You can do a bunch of stuff with killing the processes. Okay, so HTOP is nice, and that's a good program to run to understand what's going on. If you thought your system was running slow, you'd pull this up and say, what's causing me to do this? And in a web server context, okay, a lot of times the big hog is MySQL. So you'd see like MySQL process 99%, and that would be a bad thing. And then you'd have to look at, well, what's hammering MySQL? Does it have enough memory? Does it have enough swap space? What can I do to fix this? Do I need to purge some of the files, the temp files out of and drop empty tables out of my database to make it run better? When you're dealing with WordPress or any of those web-based tools, processes are important. So, and I think I can just exit out. So F10 quits the program. Click in. So HTOP is good. Better one that's more graphical and better to look at here is BTOP. So BTOP is something you would install on your package. Okay. Just like running Windows, where you'd go and download a package manager and run a Windows install. In Linux, you can do that. You can do it through the GUI, and there's a whole version or variant of that through the GUI. But there's also a way of installing things on, and there are a couple different, we'll call package managers in Linux that allow you to place an application in there. And then you also use that same process to update and remove them. And in your standard Debian Linux, that would be like a very simple APT command. So APT does your updates and stuff like that, and it's a good program to run. And I'll get into that, and I'm going to show you an alternate to APT. But you can see here how this is a much cleaner, nicer way to look at your Linux system, because it's giving you a better breakdown. Shows me my network usage, shows me my processes that are running, shows me my CPUs that are running, and I can customize this as much as I want. There's different buttons you can hit to customize it. So here's your options, and we hit quit. Hit quit. Okay, that's BTOP. Back to the list here. So we went over HTOP, we went over BTOP. I'm going to show you one called IFTOP. Okay. what I did there was do sudo. Sudo is escalated privileges, kind of like running as administrator and the other thing. And what this does is this is kind of like the netstat, but it's more towards your interface. If top is your interface, topple situation. So who's connected to me? Where are they connected on? And how much throughput are they connected in what direction? So when you start to hammer a box with DDoS attack, you'll see this is where you would see it if you were in the blue team side and looking for it. Question so far? Keep moving. So that's IPTOP, and it shows me the thing. Now, when I was in the other computer, the Windows side, I did ipconfig. In Linux, it would be, there's a couple variants of this. There's ifconfig, which will give me a similar type output showing me what my IP address is. This is, remember, local loopback, the self address. And then this is the wireless LAN address, which is not connected, okay? There's also something known as IP and then just the word IP address. And that'll give you another version of the same thing. So there's more than one command to do the same thing. The ifconfig is part of a network tools package that I installed. So let me loop back to that and go over installation of things. So I'm logged in as me, so I'm not the root account. So in order for me to do root level stuff here, I have to say sudo, okay? And so I would say sudo apt update. This is your most basic thing that you'll do on a Linux box, okay? What this will do is this will go out to the public libraries and grab all the libraries and upgrades that are there that can be upgraded. Now, in order to run these upgrades, you would say the same thing, sudo apt and then upgrade. And that would update the system. It's kind of like running Windows Update on your computer, very similar. So you would also use this to remove a package. If you wanted to take a package out, you'd say sudo apt remove, and then possibly the package name you want to remove off the system. Now, that's one way of doing it. There's another program called Nala, N-A-L-A. Nala is kind of like, if this was H-top, Nala is like B-top, where it's more graphical and more easy to understand. So if I said sudo Nala update, you can see how just the initial, it says the same exact thing, but it looks different. And when I go to do the update, I say upgrade, it'll keep it in a way that I can actually understand what's going on here in my packages. So you look at this upgrade and what it wants to do, it's going to auto remove all those old headers and old information, and it's going to install the top two things, which is a Firefox update and LX input update. The variations that we're going to are the builds from one to the other. And all you do is say yes, enter. Now you can see that it's going to do a nice little job of doing what it's supposed to be doing. This is a much better way to look at your upgrade using Nala. Nala doesn't work on every package, and sometimes you have to connect to if you're using maybe like an Arch or another variant of Linux, you might not be able to get Nala on there unless you point at a specific repo to install it. But it's a good starting point for updating. So that system's now updated. Don't have to reboot, don't have to do anything. If I don't want to see all this stuff on the screen, I just type clear. Clear. And now I'm back to my terminal. So that's a good way to like flush your system clean. Another command that's interesting to type in is history. Okay, history will show you all the different commands that you've run in the system. And the up arrow will allow me to recall in order those commands. So it saves like the last 100 that you typed in. That's helpful when you're doing like big Linux jobs and maybe you had somebody else do something for you and you got to now recall that. And figure out what they typed in before to restart a process. So the same thing with processes that exist in Windows, there's processes that exist here, there's a system manager in Linux that runs systems. We're not going to go too deep into that this time. So another program that's interesting is this one called NeoFetch. And NeoFetch is an installed program, but it's just a nice little additive program that you can put on any system that'll give you the basic system information of what's going on there. Neo, like the Matrix, has a lot of different sub-variant programs within here. There's a Neo Vim. Who knows what Vim is? Yeah, so Neo Vim will allow you to do an enhanced version of Vim. Vim is a text editor, for those who don't know. There's also the most basic text editor that everybody uses is what? Nano, yeah. Nano is the most basic one. Vim is a little more fancy of a text editor. There's text editors built into Windows. I think Pico is the name of the Windows text editor.
Yep.
Well, yeah, Notepad, but in the actual, let's see if it's still there. I forget what it was called. It's been a while. But Windows has their own version of a text editor, very similar type thing from a system control standpoint. So that's an interesting one. Neo, there's a whole sub-variant of Neo packages that were developed out there. All the stuff I'm showing you is all free. So now we're going to look at Ranger. Now, what Ranger is a very simple program for looking at your files. So first, I'm going to show you how to look at files one way, and that's the ls command. This will show you directories, ls-la will show you files and permissions, ls-l. There's a bunch of different variants here within this that'll give you a bunch of different things. What these things mean here are it's telling you it's a directory and its permissions. This is read, write, execute, read only, etc. You can change permissions on files, and the top level person, being the root account, can access anything on the system. So this looks like Windows because on top of this is a GUI that if you plugged a laptop and keyboard into the Raspberry Pi, you would get. So Ranger is another way of looking at the, there's a bunch of other ls commands, but Ranger itself is more like, I would say, like Windows Explorer here, where you can jump around within the folders using your mouse and keyboard to look at files. Okay, and I can go all the way up to the top root directories here. This is the top root directory and then the top folder level underneath that. So the slash mark here is the top, and then these are all the main root directory folders. You might have seen etc. That's a very popular folder to go in, and most of your configuration sits in here. And if you look at stuff like cron, anybody know what cron is? What's cron?
Job scheduling?
Right, so job scheduling. So within Linux, you have the ability of setting up scheduled tasks to run whenever you want. In this case here, the cron daemon can set up and run daily, hourly, monthly, weekly, yearly. When do you want to run it? You want to run some kind of update? You want to have it reboot? You can set it as a cron job that'll reboot every 24 hours. You can have a service restart with a cron job. Okay. If you want to kick everybody off your computer, you could do that with a cron job and then put them back on later on. So under the etc, there's a lot of different functionality type folders. And then you can see underneath of that is subfolders with, this is actually a file here. So that's the file. As I keep going over, it actually shows me the file. It's a way of browsing and looking at stuff in your system without having to go through all the commands to open it up. Just escape that. That would be to nano edit it, Control X. So you can see you can jump around. Ranger's a fun little tool that'll get you used to jumping through the directory systems in Linux. Questions, concerns? Everybody knows all this stuff already? Am I teaching something that you guys don't know? Or you do know? Some of you know it. It's okay to say if you don't.
I've almost never used Linux.
Huh?
I'm not a Linux person. I've almost never used Linux, basically ever, so.
Well, in the competitions that you guys are gonna be going into. Linux is half the battle. So half the team is Windows, the other half is Linux. So you're gonna wanna know that. You're gonna wanna know enough about it to know that there could be launching attacks. Linux is not as easy to detect attacks on, and it's not as easy to break into as Windows. But a default Linux installation is very easy to get into. And most places, when they give you these competition systems, will leave a system open with the intention of you going in and locking it down. So knowing how to create users, knowing how to delete users, knowing how to add users, and modify their permissions is very important in this realm. You know, I think one of the first things we did in the last competition was go through and audit the systems and then change all the passwords. Because they hand out 20 systems to everybody with all the same configuration and passwords. You're gonna wanna go in and change them to something else immediately. All right, let's get back to the list. All right, so now we're getting into more of the network-based tools. So I'm gonna jump around here. So there's one tool called Nmap. Who's familiar with Nmap? Right, so Nmap is a network scanning tool. So if I wanted to Nmap something, I could Nmap an address. And let's say I just did the host system that I remoted into. Wait, I'm gonna run this off the Cali side. So that scanned one system. I wanted to scan the entire subnet. Okay. In this case, it's what we call a /22. And what it came back with was these ports are open: 135, 445, 2179, 3389, so on. And these are all related to different programs that are running. This is something that you would do in your security audits during the competition to see where you're exposed from a blue team perspective. From a red team perspective, this is where you go in and try and launch exploits. So Nmap has some basic built-in scripting that we could run against the system. So we'll pull up some cheat sheets here. So using -- script and then malware against the host. We'll run a detection based on whether or not any malware ports, well-known malware ports, are opened up on the system. And it's easy to like do something like this. The advantage again of, so what it's going to say is didn't really detect anything. So, and then the other one that I was going to show you guys that's a pretty easy, quick one to run is the vulnerabilities. So this one is a little more extensive. Type in ULN. Now, the reason I'm doing this one first is because this one is the slower version. What that means is that I just scanned one host. What if I wanted to do the whole subnet? How long do you think this is going to take? I would leave and go get a drink and come back, because I'm not going to sit here and wait for this thing to sit here and clock like this. Obviously, in a terminal environment, you could run more than one terminal and have more than one system. So you could launch this on one system and then terminal into another. I could remote into the same system and launch a different session within the same system and start doing stuff. So gave us a base result. All hosts are up. not vulnerable, discovered hosts 224.0.0.251. That's a multicast address. Saying null UDP for DDoS. So it tried to launch this CVE against this host and it didn't detect it. You can look up what the CVE is and then you'll find out what the actual vulnerability is. So this is like a very quick on the spot audit of a system. Okay. I didn't have to know anything. I didn't have to know what I was looking for. I just said, look for vulnerabilities. And it went out and did it. I think it's still running. Yeah. So here, it couldn't negotiate these, it couldn't negotiate these. These are the ports that are open, and then it errored out. Took 87 seconds. That's a long time. You know, in computers, that's a long time. So to do the whole subnet with something like this, if I was to do .0/22 -S, this will take quite a while. I'm not going to run it with the vulnerability. I'm just going to do it with the open port. But here it's going to do the whole subnet and hit every host. It's going to take a very long time. I'm not going to let it run all the way through. But now there's a Windows variant of this. You can install Nmap on your desktop. That variation is called Nmap. And it just runs as a Windows executable. You'll obviously have some issues with Windows Firewall and having to unlock that side of things. And, you know, people won't like that you're doing that kind of stuff. Again, it's going to sit here and clock and clock and clock. So I don't want to sit here and waste time doing this. So I'm going to show you. There's another program that's much faster. See, it did 214 hosts. It's only 14% done, 15% done. You know, there's a lot of hosts here, and it's just doing what we call the stealth scan. It's only one part of the scan. I'm going to kill the process. And the other thing I was going to show you is a program called Mass Scan. So Mass Scan will allow you to search, and then this -P will allow you to specify a port number. So let's say I want to see what systems on this subnet have Telnet open. Telnet's port 23. I say, now, if I want to do the entire university, I would say 10.0.0.0/8. That would cover all, I don't know, 4 million addresses that are in that pool. But I'm just going to do 10.16, just the one I know about here in the building. 0/22 P23.
Can you
Look how
explain
much
the
faster.
/22?
What's that?
Can you explain the /22?
What?
The /22.
Yeah, so the /22 is what's known as a CIDR representation. That's CIDR. And that is the subnet mask. So so it just completed the entire subnet and it did it in several seconds and told me that all of these hosts are open on Telnet, which is clear and open with no security. And I could try and Telnet into them if I wanted to. Not a good thing when you're security auditing inside the OIT building for these things to be open. Who knows what they are? They could be just UPSs or stuff like that. It could be hosts. It doesn't really matter. The point is when you're doing your security auditing, this is the type of tool you want to use. Sit there with Nmap and let it clock. You're going to waste precious minutes. So let me get back to this the slash thing. So we already said that if config shows my IP address. Okay. And my IP address has a net mask or a subnet mask. In this case here, it's 255.255.252.0. Okay, so I'm gonna get up and use that board and explain this to you guys in the most basic way. Most people are familiar with their home routers, and their home router would be a slash marker. Marker. First. There. So most home routers would be like 192.168.0.1, and then it would have a subnet mask of 255.255.255.0, right? That's, and then they would have a gateway. This would be the gateway, and maybe their IP address is 192.168.0.10, and that's the host. This is the host, this is the gateway, this is subnet mask. Okay, so what these are is what? What are these numbers?
Addresses?
Right, they're addresses, but what are they made of? The binary addresses, right? What's a binary address? A 1 or a 0, right? So it's the 8-bit binary scale, most basic scale that we work with. It's the easiest one before you get into like hexadecimal. So you have numbers 1, 2, 3, 4, 5, 6, 7, and 8. Each one of these can be a 1 or a 0. I can either be a 0 or I can be a 1. Be a 0 or I can be a 1. Be a 0 or I can be a 1. Be a 0 or I can be a 1. Be a 0 I can be a 1. 0 or I can be a 1. Be a 0 or I can be a 1. Be a 0 or I can be a 1. Each one has another number associated with it. Okay, so this is 1. Put this line here. This is 2. This is 4. This is 8. 16. 32. 64. 128. These numbers all look the same, right? Like Commodore 64, 128-bit encryption, and you've heard all these numbers before because everything runs off this type of scale. So if my numbers can be this, I can make any number of any combination using these numbers down here for values. If I add up every number on the list, what do I get? 1 plus 2 is 3, 7, 15, 31, 63. 63 plus 64 is what? 120 what? 127. That sounds familiar, right? Didn't we talk about 127.0.0.1? Okay, 128. That's 255. How many numbers do I have? No, how many different numbers can I make?
256?
Right, why? Because 0 is a number.
Yeah.
So if all of them are 0, then 0 equals 0. If all of them are on, I have 256. Okay. Now, in the general rule of thumb, you can't use the first one, you can't use the last one. So this is known as the network number. This would be the first usable number. 255 is the last usable number. So this is a locking position. Now, where subnetting gets fancy is understand the concept that in subnetting, you don't create any more addresses in the block than you have. You make smaller networks out of larger ones. We all know about a Class A, Class B, Class C address block space, right? If you don't, I can explain it, but.
I've never heard of that.
Okay, so Class A is 1 through 126. Okay, that means the first number in the IP address falls in this.
Okay.
Okay, then there we have 127, which we know is what? Local loopback.
Yeah.
Then we have 128 through 191. This is a Class A, this is a Class B. Okay. Then we have Class C, and that's 192 through 223. There's a Class D of 223, 224 through like 240, I want to say, and then there's a Class E after that. These are, the original internet was designed this way with IPv4 address spacing. And when you have a Class A address, that means that you lock in the first octet of your IP. So in our network here, it's 10.16.8.x/22. What that means is that this is a 10 address, so under classful rules of classful networking, this is the thing that identifies the network you're on. In this case here, the 10 is a FAU network. Now, there are significant numbers in this pool that are for internal networking. Okay, 192.168 is one internal network number. 10.x.x.x or whatever is another one. And does anybody know the third one? Okay, 172.16 through 32 is your class B internal addresses. What tells us who's here as a member of the IEEE? Junior member, associate member? I've seen you guys post stuff about the IEEE. Who knows what the IEEE is? Yeah, okay, so the IEEE puts out documents on how the internet works. The documents are RFCs. This is the most smug way of saying this is how we're doing things. RFC stands for request for comments. It's like, here's how we're going to do it. You got a better idea, let us know. Here's my email address. But until you come up with a better idea, this is the way it's getting done. So the RFC that dictates internal addressing on IPv4 is 1918. You can look at that up on your computer, just type in RFC 1918, and you'll get this basically text document that will show you, what these addresses are. This one, that one, and the 10. So at FAU, because we're on the inside of the network, we have a 10 network. That gives us several million internal addresses to use. Remember, I said a subnet mask doesn't create more addresses, it segments them into smaller blocks. In this block here, consider these a locking position. Okay, if I turn all the bits to 1, I get a 255, then I lock this in. That number is not going to change. That's part of my network. This one here is locked in as part of my network. This one here is locked in as part of my network. If I'm on a different number here, I'm not on this network. I'm on a different subnet range. Okay, like if this was a 1, that's a different network. If it's a 0, it's on the same network with this host. If I put the host on a 2, it can't talk, it won't work. Okay, because these things here are locked in because you're bit locking them with these 1s. Does that make sense to everybody? Okay, so .0 gives me a usable range of a class C address of 1 through 255. We said we can't use the first one, can't use the last one. So there's 256 addresses. How many usable do I have then? 254, right? So understand that if I was to write this out in this format, it would just look like this. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 0. Right? What's 8 plus 8 plus 8?
24.
There's your /24. So if I have a /22, I now convert this one to a 0 and this one to a 0.
That's just the number of bits that are high.
The hot bits, right? Not number of bits that are enabled for use in the subnet.
Yeah.
And a /22, I created less networks than a /24, but they're bigger. How much bigger are they? Well, if I had a /22 of 1016.8.x/22, that goes to 9, 10, and 11 times this number. So 4 times 254, give or take an address, it's about 1,000 addresses. Okay, so for this building, because we have, let's say, 200 employees, each employee has, let's say, 3 or 4 devices. We assign subnets of /22s is what we use for a standard building subnet. For employees, for students. It gets bigger, the bigger the pool. So In our wireless networks, where we have 30,000 wireless devices connecting, we have several different subnets being fed out there. But we use like a /16, /19, depending on what the subnet is for what it's for. And those are just basically giant address pools that we allow people to connect into. And what is the address pool actually? It's a broadcast domain, right? So if you're in this address space, you can see everybody else in this address space without going through any kind of filter, gateway, firewall, whatever it be. Okay, so the bigger the pool, the more users in the pool, the more congested it's going to be. The smaller pools, easier to control. Standardizing pools, like using standard sizes like a /24 or /22 or /23. So labs, the lab team that runs the computer labs, they typically use the /23 for a building. Because they'll maybe have 2 or 3 computer labs in the building with 30 or 40 computers in each, and that 500 addresses is plenty for them. Okay. Wireless, we have way more. Wired users, we typically go with a /22. Sometimes bigger, usually not. In a secure network, so what's the smallest network I can have? What happens if I turn on all the bits except the last one, let's say? So take rid of that, get rid of that. And so we had 8 here, and now I'm going to put on another, let's say 6. 1, 2, 3, 4, 5, 6, 0, 0. How many do I have there? 30, right? So 6 plus 8 plus 8 plus 8, 24 equals 30. How many addresses are in /30? There's 4. What's the smallest I can have that's usable? I can have all ones. Okay. If you look at your local loopback, the subnet mask should be 255, 255, 255, 255, which is basically all ones saying locally doesn't go anywhere. The smallest one you would have would be like this, and that's a /31. It's not really used a lot, but it gives you 2 addresses, start, finish. It's good for router point-to-point links. Why is subnetting very handy? The smaller I make the networks, the more control I have over them. If I'm building a transit network between the firewall and the router, I want that network to have 20 different addresses possible in it, or just 2. It's what we call a point-to-point, point 2. The DMZs that the security team rolls out are typically 27s. Another thing that the security team here likes to do that's I find a little goofy because it doesn't really matter, is they don't use the standard gateway. So standard gateway is always usually the first usable address of the block. You can see any of this stuff from your computers if you type in subnet calculator. But the first usable address of the block might be a .1 if you're at the first part of the block. Okay. They'll use the last one. They'll make your gateway 254. Just thinking that they're throwing people off. But anybody that knows how to hack is going to figure that out right off the bat. So anybody who's hacking is not going to fall for that. And so it's not, I guess it gives them a level of comfort that they're using the term security through obscurity, I guess is the term, but it's not a real thing. So questions about what the /22 means, what subnets are, how this whole works. We can go into further detail, but understand that when you get down to this 1 and 0 level, you're dealing with electrical pulses, okay, and voltage. And that's what's in your computers, right? They're all running on power. And when you use your Ethernet card, you're modulating those electrical pulses out onto the wire and then demodulating them on the other side. And there's a whole level of build up and tear down that occurs between point to point and multiple layers. On top of this, on top of IP, is those port numbers, TCP, UDP port number system. This is not the only protocol that exists at level layer 3. Anybody know of another layer 3 protocol besides IP? No. So understand that when I talk about layers, I'm talking about the OSI model. Okay, which is a 7-layer model, 7, 6, 5, 4, 3, 2, 1. Layer 1 is your physical layer. That's the actual wires connecting between devices. Layer 2 is known as your data link layer. We'll get into that in a little bit, but understand that there's a system underneath of this system that ties your IP address to what? What does your IP address correlate to on your local system? MAC address. MAC address, or your media access address, is a hexadecimal number, another topic for another time. But hexadecimal numbers, like binary numbers, translate back and forth, but hexadecimal numbers start at 0 and go through 9, right? So how many numbers are there? 10, right? And then A, B, C, D, E, and F. Okay. So a hexadecimal number goes from here to here. If I have all F's in a hexadecimal number, it's basically all ones. If I have all zeros, it's all zeros. Anything in between this is a combination of a 16-bit number, okay? Because there's 16 different positions here. If you count them up, 1 through 9, 10, 11, 12, 13, 14, 15, but 0 is a number, so 16 positions. Your MAC addresses are on every device you have. You cannot talk on the network without a MAC address. MAC address is a layer 2 type thing, and that's how we trace information back to a user, okay? So you can see your MAC addresses inside of your computers with a very simple command called ARP. ARP is ARP, and then you type that into the command prompt, and that stands for Address Resolution Protocol. So in Windows, I'll show it to you guys here. Command prompt here. There is ARP-A, and you can see the physical addresses of the ARP table of what's connected to me and what I've connected to. If I do IP config /all, here I can see my MAC addresses, my physical address. That's the MAC address. That's the hex address. That's in hex numbers. Anyway, let me jump back on topic here to, everybody holding up okay? Nobody needs a break? Computer disconnected from what? Do you guys know what all these networks are here, the edge roam? How many people know what edge roam is?
I don't know what it is, but I'm connected to.
Heard of edge roam? When you connect to Wi-Fi here, do you connect, what do you connect to?
Connect to the EDU room.
Edge roam? Okay. That's what you should be connecting to. That's our most modern network. VPN. Reconnect to WPA2, network connected. Reopen the VPN. It might go to sleep. Not a fan of all the security. It gets in the way of everything. Terminal back to the other machine. So RDP has its own well-known port numbers too. And so when you're establishing sessions or remote sessions to a system, RDP would be one of the ones that you would detect. Only a few more commands, and then we actually have some fun stuff I'm going to show you guys that you'll be able to try on your own. So historically, IP is not the only protocol. There's other protocols out there. DECnet, which is a protocol that came from Digital Equipment Corporation, which was before everybody here's time. Nobody was born when DECnet was around. And then, stuff like IPX. IPX is a Novell protocol. And Novell protocols Novell was the competitor to Microsoft back in the day. Okay, and they developed the first Active Directory system. Microsoft copied them. In IT, it's a series of copycats. You do one thing, I do another. He develops MySpace, I develop Facebook. Okay, you see how that formula works out? You develop a PC, I develop an Apple. It's a constant reiteration of the same old crap in a different way. Let's get back to our commands. Cheat list here. Get through a few more of these for you guys. So we did mass scan. We did H ping 3. So we know what ping is, right? We can ping a device. I can ping Google. And that sends a message out to Google and comes back to me. Okay. H ping is like a ping command on steroids. Up here. You guys can see it. Let's do address 10.16.8.5. Okay. Yeah. So the flags for HPing allow you to do some pretty nifty things that ping can't do. The one thing that everybody likes to do with HPing is this one here. Okay, so if I change my packet size to the largest size available, and then I tell it to dash flood, basically launching a denial of service attack against something. Okay, and if you use if I run this between systems here, just to show you guys what that would look like. Down. The other one back up. Okay, so this system here is the address is 10.16.8.212. So from this other system, first thing we'll do here is let's start our counter. So we said if top, right? Maybe we have to do a sudo. So now we're watching what's coming into the system. There's not a lot, but so from here, I go ping or hping 3. Let's just do ping first. Ping 10.16.8. 8. Is it 8? Yeah, 8.212. Here, you'll see the ICMP addresses will start to come in, and it'll show up on this list here somewhere on the top. I think it's bigger. You'll see that you're getting pings from this system. That's what these are here, the 48 address. And I'm doing a continuous ping, and I wouldn't say it's doing any damage, okay? I mean, this system will work just fine. Control C and kill that. Now I'm going to do the same thing with hping 3. 10.16.8.212 -- flood. And let's see how much traffic. Oh, we just slammed the thing with 25 megs. Now that doesn't sound like a lot, but if I wrote a script, I can make this run 25 times. And then boom, it just slams it with 25 different sessions of that. I can make it random. So another thing that you can do here that's really messed up. So it knows who I am there. So if I did this, I would be busted, right? So I don't want to get busted. So let's take a look at what options we have that we can unbust ourselves. So dash help. And you'll see that in HPing 3, just me highlighting and clicking the wrong way. I'm not really good on a laptop, believe it or not. There's a section here where we'll see that we can tell it to use, let me make this bigger so I can see it. Random sources, okay? So random source, see that there? So Control C. Now, if I do this, and then say dash random dash sources, right?
Pretty sure it was random.
Smaller, so we can see what happens here. So now this system is getting hit. I think it might have already locked up. Yeah, so the process locked up on the other system immediately. It doesn't like getting hit, especially these little boxes like this. Other session. Take a look at it now. We'll do it again. So now we're hitting it with random sources. It might have overloaded it to begin with. I'm going to turn this off, see if it catches up. Typically, what you would see in this section here would be the flood. It's locking it up. Basically, the application can't handle it. Might have jammed it up enough. So remember I said you could run btop and see what's going on. It wants to be bigger. Okay. So here, not much going on. Processes and whatnot. Let's switch back to our other one. Let's run it again, see what happens. Switch back here. Let's see if we can get it to run a sudo ibtop. So basically, I launched a denial of service attack from one machine to the other and locked it up. Okay, and it's kind of intentional because we're kind of playing around with these things. If I did this on Windows, it would work to some extent. Remember that, there's firewalls involved on certain systems, so you have other things blocking you. But we're still running the package. Let's just see if we can btop and see what's going on. Okay, so you can see the graph down here has gone from nothing to 6 megs a second. It's basically, you're throwing a lot of packets at it. So far, we've sent 2 gigs worth of garbage at the machine. It's your most basic like DDoS type attack that you can run. There's other variants of this, but I just wanted to expose you guys to what's out there so you understand what you're up against and how to stop what's going on. Okay. I think if I stop it, I might be able to capture some of this. So another command, I'm not going to go into too much of them more. We went over Nmap. So this is a good one to run here. This is running a tool called WP Scan. So who's in charge of the WordPress for us? Anybody here? No,
No, just me.
it's you so far. So everybody knows what WordPress is, right? This, I have a token built into this command here. But this is a third-party security tool that we can run off of the command prompt that will audit our WordPress install. We'll run this from Cali and point it at our actual web server. So has everybody seen the web page? So we have a web page. It's at csc.fau.edu. This is the WordPress backend of it. And this is the front side of it here. You guys have a web page that we put together. On this web page, there's information about the Discord, there's member hours and information. We have social links to our other things. You'll see we're still working on it. So we put this together, I want to say like a couple weeks ago. And if you look at like what's going on, you can get some information there. We don't have any merch yet, I guess. But this is posted here. I had this set up at FAU on one of our VMs in the back room in the data center. So you guys have your own presence of CSC, you know, the cybersecurity club at FAU.edu. Least amount of keys better. But to run, let's go back to our scan here. To run our security scan against it, I'm going to run this key here. I'll say no, I don't want to update now. Just run the scan. But this was a specifically made tool for looking at your WordPress site to make sure it's secure. So this WordPress is running on, where did we say it was running on? Apache, right?
Yeah.
So this is on an Apache web server. You'll get all that information out of the security scan here. Like it will tell you, it's kind of, understand that the security scan can be run against any package you want, any server, web server, any website can run this against Google. You know, what it tells me back is going to be some relevant information into what we call footprinting. So footprinting is how you enumerate or investigate a target. So here, it ran it against our thing and said, no config backups found. This is some information about data. Here's the URLs and stuff like that. And all the different files and themes that we're running, what the theme name is, where the theme comes from that we're running on the front page. So basically, this did detect a vulnerability in the theme Rex add-on with the remote code that you could then look up these exploits and see how to actually exploit the system. So it's doing the enumeration for you of a web server and then saying, here's what's open on it that you could go after. And if you look at this, you can see here the CVE date is 2020. It's not, I already checked these. So we're not susceptible to this stuff. Understand that if I was to scan, let's see, if I was to Nmap csc.fau.edu, I would be able to see what's open on. Right? So those are the ports that are open on 80, 113, and SSH. Now that's from here. If you run this on outside internet, because this is on the inside network, you're going to see a different picture. Does that make sense? Because we're inside the firewall here. Inside of FAU, we have more stuff open than outside of FAU. Okay, so from the public internet, you might only see 443 and 80 open. Questions about that? All right, let's keep going. We're almost done. Is this too much for you guys? Okay, so what web? That's an interesting command. And let's look at fau.edu. It's just another what we call enumeration tool. And this will give you some information about that. So this tool here shows who's the web server on. It's on Apache. What version of Apache, what cookies are enabled, all kinds of different things. You know, what PHP version they're running. So it's a nice, quick, to the point, check my domain or IP and get some information back. If I run the same thing on csc.fau.edu, you'll find something different. So, first of all, our IP address is different. So either we're on 129, they were on that one. We're on Apache 2.4.58, they're on 2.4.6. So our Apache version is actually a later patch version than the actual web page Apache engine that the university is running. Maybe they need to update. I don't know. Ours tell us we're on Ubuntu Linux. They're running on what we call the F5 Big IP. Okay. So what's the difference there? This is a Linux server. Who knows what F5 is? So F5 is a company that makes load balancers. Okay. Load balancers on a front end. So there's multiple versions of the website on the back end being held in like a clustered environment. And the F5 load balances the traffic from there. So the only thing you see is the F5 because that's the only thing in front that's publicly exposed on this one. On this one here, we're going directly to our server. Okay. And you can SSH into the csc.fau.edu if anybody's interested in being, who do we have as the, you're going to be the admin for that? Right, so he's going to be doing all the updates and patching. Right now, I've been doing it, you know, on a weekly basis as I see necessary. I go through and typically update a bunch of different stuff at the same time. Just out of habit. So that's WhatWeb, nice little quick tool for command line and Linux. Let me go through some other stuff here. Back to our list. We're on the last thing. So I'm not going to SSH into this one. I'm going to let you guys follow along with me. You go here and just type in telehack. Okay. This is going to open up a command prompt for a very old system that was set up a while ago. Or you can telnet into this from the public internet. We don't allow outbound telnet from inside the network here, so unless you're on your own internet, you're not gonna be able to telnet into it. I'm not currently telnetted into it. How am I connecting to it? Through a browser. But I do have a telnet session, so I can do Linux-based commands in this thing. Now, there's a bunch of fun little tools and games in here that are all the original, historic, first internet generation type stuff. Okay. There's also some documents worth reading. The Be Cool document kind of says, you know, don't be a jerk. In some nasty words as well. There's simulators in here, like this war dial simulator. So war dialing was something done back in the day when people had modems. And the war dialer will actually go through and just continuously call until it gets a connection. I'm pretty sure this is just a simulator of that, but it allows you to experience what they experienced back when war dialing was a thing. Port hack is also another tool. So the ones that are executables or are actual applications, okay. The other ones are files themselves. And we'll run through a couple of them. You can create an account on here for yourself for free. So you would just type in login and then give it a username. So let's say Kermit 1. Since Kermit 1 is not a user on the system, it's going to say, would you like to register? Yes. For your further use, do you agree to the policy privacy? Read now. No. Set a password for Kermit 1. Enter. Enable password resets now. Now I'm logged in as Hermit 1. So if I wanted to see who's logged in, I could run a command to show me like finger. And that's showing who's logged into the system currently and their username and their status. Okay. And where they're at. Okay. I'm using that to find it. These other people, where they're at in the system of what the last command they ran and where they're coming from. So again, this is like a toy. So if you want to jump around and play with a Linux-based system without ever worrying about breaking everything or even having to set up anything, this is a very basic toy. If I wanted to do set status, I am here. Okay, right? I can set my status to whatever I want. Let's say finger. My status has changed. I am here. These other people, you can talk back and forth with them. They're connected through the same system you're connected through. Okay. So now that I'm logged in, you have what we call elevated privileges as being a login and just the .guest. So let's take a look at our files again. If we were to run war dial, say yes, enter an area code number or a question mark for a list. I'll tell you right now, we could put 305 in, that'll work. 561's not in there. But if I put 305, it'll start scanning 305 for connections. It's going to attempt to make a dialed up connection to a remote computer. It'll either get a busy signal, no carrier, so nobody's at the other end of the line. And again, this is kind of a simulator. It's not really doing this stuff, but this is how it used to work back in the day. And this is what, when analog modems were the way of connecting, this is how people would hack each other. When you hack over the phone network, what are you called? Anybody know? It's kind of like a P. Diddy thing. They were called freakers. Spelled with PH. PH for freakers. The original hacking was all done on the phone system. Originally, it was done to make free phone calls. Okay, so I'm connected to someplace called Glasshouse. Gave me the phone number, gave me who it is, enter your username or guest, we'll just say guest. Access privileges granted, press any key to continue. If you want to look at what files are on this system, here are the files on the system. So it's kind of really giving you the experience of what it would be like to terminal hack into a system. You've dialed in, you've gotten in, it's pretty open, it's not really locked down. And if we want to quit, Control-C or quit. There, disconnect. Okay, so dropped out of that. So that's fun. Let's take a look at some other more interesting things. One of the things I like on here is called Aquarium. I think it's on here. Let me see. What this does is this turns your terminal into a fish tank. Kind of like a screensaver. And it'll just sit there and run. So maybe you dial into telehack on one of your terminal sessions on one of your side windows and let this run because it relaxes you. And it's just making little fish out of terminal key characters. ASCII code is what it's really called. So that's interesting. Another one that everyone likes to do is the entire movie of Star Wars is on here in ASCII code. So I type in Star Wars. It'll play the entire movie, start to finish, in ASCII code. With all kinds of characters being used for everything from the initial It's just like a standard file that's being played into the system with the script. But somebody took the time to actually make this, says something about free time and what you do with it.
Too much time.
Well, remember, back in the day, connection speeds weren't what they are and applications were limited. You only could call other computers and do several other things. So, in 1978, when Star Wars came out, this was the level of communication that you had on computers. So that's supposed to be the ship. That's the other ship. So it's really fully animated movie that you can watch. There's R2D2 and C3PO. And they're going to go through every line of the entire movie. So that's a fun one. Let me show you guys. Before the big video games that everybody plays now, the Call of Duties and stuff like that, video games were very, very basic. And so the game Adventure, okay, was one of the first games released out there back in 1976. Okay. And Adventure starts out as a story. It says, at the end of the road, you're standing at the end of the road. Before you is a small brick building. Around you is a forest, a stream that flows out of a building down a gully. So, basic things you can do here is you could say, go in building. Okay. You're inside a building. There's a well house, a large spring. There's some keys on the ground. There's tasty food here. Shiny brass lamp is nearby, and there's an empty bottle. You could go through and say, take bottle. Take it. And this is the way games used to be originally on the computer. So this is like a throwback to what the original text-based adventure games were in 1976. This is how things ran. You can say, go outside. Okay, you're now at the end of the road. I could say, go west. You've gone up a hill and through a forest, slopes back to the hill. There's a building in the distance. Go north. You're at the end of the road. West. You're at the hill and look. Tell you where you're at. You can see how basic, but it was programmed well enough that you could type in just about anything. You can see run. Say. You'll have to say which compass direction to go in. See, they kind of came up with a formula to interact with you that no matter what you say, it's got an answer. Kind of like the first AI. Anyway, we'll exit out of that. You're back to your thing here. So some other more interesting things in here. Has anybody heard of the term the rainbow books? Okay, so you see there's a word that says orange book. So if I type in orange book, the rainbow books were the original orange book. Okay, the original Department of Defense computer security guides were written on something known as the rainbow books. So it was a series of books based on colors, and the colors dictated the levels of security. The orange book is for trusted systems and evaluation. Then it goes into how to secure a system, and this is the actual document from the Department of Defense from 1970 something when the original computers came out. What were the original computers used for? What were they built for? Does anybody know?
Calculation.
Calculation of what? Okay. So the first computers were built to calculate the trajectory of missiles. Why would we be concerned about the trajectory of missiles? So in 1972, did we have nukes or not?
We did.
We nuked Japan in what year?
45.
45. So 25 years later, you have computer systems that can calculate trajectories of nukes. These books were written on the computers for the computer systems that run the nuclear control systems. Again, this is all historical, fun stuff I'm showing you guys as a toy. The other stuff, the other commands are real. This is more like you know, and if you wanted to know about this stuff, you could just Google it. I could pull up another tab and type in, you know, rainbow books. See, this is what this is about. And then you get into you guys know the NSA, right? So the NSA has escalated that to newer things. And if you look at like your NSA, you can pull down the NSA guides for securing. You'll get the NSA document that talks about what things to turn on and turn off in Windows 11. It's all recommendations and stuff, you know, what services to allow, what services to not. You know, it all spawned off of those original books that were all written by the DoD to control the nuke system. So, telehack is a toy to throw back into the days of old. One of the other, I think port hack was it? Yes. Question mark. So as you can see here, this simulates actually breaking into real places. So we have Lockheed Artificial Intelligence Center, Oracle Corporation. I think depending on which one you go into. So if I typed in Oracle, it's simulating what it would do to break into Oracle. And it's done a thing and says, well, what port do you want to try? We know what FTP is, right? File transfer. So if we said try 21, we're going to try and bust in through 21, try another port. You say try, I don't know, 205. Just take a random one there. So it's a game. Once you get into that system, then you could jump into another system. It's kind of like an earlier version of your hack the box type game. Very, very basic. But if you want to break out of using the console in a way that doesn't hurt anybody, telehack is a good starting. I don't have anything else for you guys. If you have any questions, we can talk about them. So this is the FAU network here. This is one of our monitoring systems we run. Well, Libre NMS, that's Libre Network Management System. What does Libre mean? Free, right? So we run a free system to manage the network. Libre is a very good system. It's free and it's vendor agnostic. We have other systems that we pay for, but this is the best free one out there that we've seen so far. And you can see like this is our internet router. And if I click on it, you see that it's Juniper. It's in the back room over here. You can see how much traffic we're doing per day in and out of the router, what our processors look like, what memory looks like, what our cards look like, everything down to like temperatures of lasers and stuff like that. So the optical power and the actual temperature of the lasers in the system, brand of the lasers. Okay, this is our hot laser here. So this one here is your 100 gig laser that's going from the router there to an optical box that then pipes us down to Miami at 100 gigs. This is the actual laser, and this is the power levels the laser's operating at. All this information would be considered layer 1 information. So we watch and see basically everything that's out there on the FAU grid. We currently monitor somewhere around 650 worth of devices. I can't read the number there, but and these are like up down statuses of things. Yellow is like a reboot. So who was here on was it Tuesday? Anybody here in school on Tuesday? We lost power for a little bit. You guys were around for that when the power blipped? Yeah, so the university power blipped on half the grid. We lost building 80, built the dining hall all the way out to the basketball and 67 because FPL blew a breaker. And so this board would turn red for, let's say, 20%, and we would see all these devices offline. Other things here, these are core inside routers. This is a firewall. So that's the FortiGate firewall. And this is just a graphical way of looking at things. We can look at a lot of different things, our routing perspective. So if you want to look at all the BGP that we run, that's all here. And this is like a monitoring tool that my team uses to monitor what's going on out there in the world that we live in. So our public side BGP is all right here. So 65,000 in BGP land is internal, kind of like 192.168. And then these numbers here are external. FAU has its own BGP AS number, and that's this number here, 12013. Understand that the AS numbers go all the way up. There's only a limited amount of them, but over AS 12013 identifies FAU. So we're tied to that. If you go and look up, you guys heard of ARIN? American Registry for Internet Names and Numbers. This is where all the IP addresses come from that are on the public side. So if you search for fau.edu, search who is instead. Yeah, there we go. AS number instead. FAU net. Wayne works here in the building. He's one of the original guys. Knock is our group email. And that's just basically all the information about who FAU is. This is our address. It's the phone number you call. So if someone does something wrong on the internet from inside of FAU, Wayne's the one who gets the call. He's in the security team and he wouldn't be very happy about it. He would spend part of his day looking for you to give you a hard time about whatever you might have done. Typically, if it's, unintended stuff, it's overlooked. Be surprised at how much stuff goes on that's not like we have 35,000 students.